we want to find out the integral of cos to the power of m of x dx from 0 to pi over 2. Now, that is equal to, I want to write it into cos m minus 1 x times cos x dx. So that way I can treat cos to the power of m minus 1 x as u and cos x dx as dv, just to use integration by parts. So u is equal to dv is cos x dx. So du, what is du? So simply m minus 1, right? Integration, differentiation chain rule. Also take power down here, so minus times cos power reduced by 1, m minus 2, and don't forget also differentiate inside function, that is cos. Cos is differentiated minus sine x. So we also have a minus in front of here. So this is equal to minus, there's a minus sign out here. So v is dv, v is sine x. So therefore, integration by parts, okay, that is, let's just call it I sub m, so the subscription indicates the power. So I sub m is now, okay, integration by parts, uv minus integral of v du, so that's u dv. So u times v. So cos times v sine x from 0 to pi over 2. That's uv minus the integral of v du, v times du. Okay, maybe just write this minus m minus 1 cos m minus 2x sine x times sine x sine square x dx. Okay, so first let's evaluate this one. So substitute pi over 2 into here. So as we know, the cos pi over 2 is simply 0. So that is automatically 0. So substitute 0 into here. So as we know, sine of 0 is exactly 0. So this is automatically 0. Now, this part, let me just write here. I sub m is minus sign becomes positive. Coefficient, take it out here. So m minus 1 times integral. What are we having here? Cos times sine square. Maybe let's rewrite sine square into 1 minus cos square. Sounds good. 1 minus cos square. Then we can distribute it onto each of these. Right? So I sub m is m minus 1. We have a of course, just another bracket here. So first of all, distribute this item onto here. We have cos dx. That's my first integral. Then I have to distribute this term onto this term. There is a minus sign. Don't forget that. So I have to minus. So cos m minus cos to the power of m x dx. Okay, so remember I indicate this integral by I sub m, so the subscript indicates the power. So since the power is m minus 2 here, everything else is the same. So this is actually I sub m minus 2. This is to the power of m, therefore this is I sub m. So I sub m is equal to m minus 1 times, this one is bracket I sub m minus 2. This one is minus I sub m bracket. Now we have we'll distribute this term onto this and that. So I m and im common factor. We can further just remove this term over there. And after that, after we rearrange everything, maybe let's see, m minus 1 minus over there becomes positive, m minus 1, there's a plus 1 here, so cancel out m times im. So m times im is equal to, still we have distributed this onto that, m minus 1 times im minus 2. This is our relationship. Maybe let's rewrite it further. So im over im minus 2 is equal to, this goes here, this goes down there, so m minus 1 over m. This is our useful relation. So, of course, the final result will totally depend on whether m is odd or even. So, let me just say if, so I don't need these. Okay, I say if m is odd, so n starts from 1, 2, 3 all the way. So in that case, so we can see there is a pattern here. So the subscripts, every time we have a subscripts up here, m, we have a m at the denominator, and the numerator is decreased by exactly 1. So here we have I of 2n minus 1 over I of n minus 2, 2n minus 3. So here the subscript of this is 2 units smaller than that. So reduced by 2 here. So equals, again, like I said, the subscripts of the top is equal to this number at the bottom. And also the numerator will reduce by 1. So 2n minus 2. Okay, so if we further reduce n by 1, we have I, so n now becomes n minus 1, but there is a 2 in front, times 2, so therefore 2n minus 2, n minus 1, so 2n minus 3 over I of n becomes n minus 1, so 2n minus 2, 2n minus 5 equals, again, according to the pattern, the bottom here is equal to the subscripts here, so 2n minus 3, and the top is reduced by exactly 1, so 2n minus 4, so, and so on and so forth. So we can multiply everything out. So in that case, we can say, okay, this multiplied by that, so I of 2n minus 1 over I of 2n minus 3 times I of 2n minus 3 over I of 2n minus 5. Okay, so here, and times all the way times, what's the final term? It should be times I subscript of should be a odd number, right? 2n minus 3, 2n minus 5, 2n minus 7, all the way down to 3. And likewise, 2n minus 3, 2n minus 5, 2n minus 7, all the way down to I1. Okay, that's our left-hand side, all multiplied together. Now, right-hand side, multiply everything together. So this multiplied by that. So here equals 2n minus 2 over 2n minus 1 times 2n minus 4 over 2n minus 3 times all the way down to, there's a pattern here. So even number, a consecutive even number, and another consecutive even number, all the way down to 2. So odd number, a consecutive odd number, another consecutive odd, so all the way down to 1, if I'm correct. Okay. So if we observe carefully, we can see that left-hand side, we can hopefully cancel everything out. So 2n minus 3, 2n minus 3, so cancel. And also likewise, this bottom and that top, the following top, cancel. So here's the pattern. So the bottom cancel with the top, so cancel, 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 all the way, this is canceled with the previous bottom. So this I1 is still here. I2n minus 1 is still here. So we're only left with I2n minus 1 over I1 is equal to this thing. I'll rewrite it as 2n minus 2 double factorial. So usually when we talk about factorial, it means, for example, factorial of n, that means the product of all the positive integer, all the way from n, starting from n, all the way down to 1. And when I say double factorial, I mean if it's a even number, that means the product of all the positive even numbers, starting from 2n minus 2, all the way down to 2. And likewise, 2n minus 1. Double factorial. It means the product of all the odd numbers starting from 2n minus 1 all the way down to 1. Right? It's 5, 3, 1. Okay. So what's I1? Because I want to find out I2n minus 1. I1 is easy to find. So just replace m with 1. So what's the integral of cos x dx from 0 to pi over 2? Simply the antiderivative of cos is sine, so sine pi over 2 is 1, sine 0 is 0, so that is 1. I1 is 1, so I'll simply erase this and say this is my I2n minus 1 if m is an odd number. So this is my result. Likewise, I'll just skip the steps and directly go to I2n. So that's if m is even. So accordingly, we can say that is equal to 2n minus 2, 2n minus. So I'm guessing it should be 2, because if I replace, according to this pattern, I2n is 2n here, 2n down here, but top is 2n minus 1, so I have 2n minus 1 all the way times the next consecutive odd number and the next consecutive odd number, because this is already an odd number. So this is the double factorial of this odd number. And what do I have on the bottom? 2n. So like I said, here's 2n, here's 2n, start from 2n at the bottom here. So 2n multiplied by next even number and next to even number. So that's 2n double factorial. Of course, I'm not because in the end, I still have something on the bottom. So here I end up with I1 at the bottom. Cannot cancel that one out previously. So here I still have I0. Because following that pattern, because that is all the way down to I1, the bottom here cannot be cancelled out yet. So if I'm starting from an even subscript here, I'm going to end up with all the way down to I2. And here all the way down to I0. So I still have I0 here. So what's I0? M equals 0. So cos to the power 0 is 1. So the integral of 1 from 0 to pi over 2 is simply pi over 2. Okay, so this pi over 2. So if I multiply this over there, then I can say I 2n is 2n minus 1. Double factorial. 2n double factorial times pi over 2. If I'm correct, yeah, 2n minus 1. Yeah. Okay, so if you've watched a previous video of mine, I've proven the limit of this integral is exactly 0 as n approaches infinity, as the power approaches infinity. So that means we can actually state that the limit of this is actually 0 as n approaches infinity. And also this limit is also 0 as n approaches infinity. In both cases, it's true. Because I've proven in previous video. But in next video, I'll prove in a different way. Still prove the same result in my next video.